I think we can go ahead and get started. If you want to condense in more, that's fine. If not, no worries. This is going to be the mock interview workshop with Google. My name is Molly, and just kind of get a quick feel for the room. How many people think of tech interviews and get nervous? Okay, cool. How many people just think they're super fun and exciting? That's what I expected. And how many people don't care at all? Good, awesome. Then you're all going to enjoy this talk. So, that is not me. That's not me. This is me. Okay, so a little bit about me. Like I said, my name is Molly. I've been at Google for about 3 years here in New York. I work on the Google Docs team, specifically the Android app, so that's for you guys who are finishing your papers on the go. We're helping you get that done. You can also see I have very lame fun facts, but I do have great trivia team names. All right. So before we start diving into exactly how a technical interview is going to go down, we're going to talk about the skills that are going to help you do well in your interview. Now, we're going to go year by year in college. We list some things that we think are great for you guys to be working on. If you've already finished that year, don't worry if you didn't do everything on the list. These are just recommendations. If you haven't, then definitely think about it, take any interest that you might have, and then also remember to put it on your resume. This is the kind of stuff we're going to want to see when we're looking. All right, freshman year. So things we're looking for is beginning interest into computer science and math. So we're looking for courses on that, starting to learn languages, understanding the logic, tracking down and reading and understanding existing code is also a really great skill. In particular, if you're interested in the engineering practicum opportunity, which is based usually for freshmen, that's something that's going to be part of the interview. So it's a great thing to get practice, kind of looking through larger code bases, working through maybe finding bugs, things like that. As well as just kind of getting some familiarity with writing code. Some of these things like version control, don't worry about that. That's something I didn't learn until you start working in the industry. It's usually something schools don't teach. If they do, that's great. Definitely talk about it, but it's not super important. Just things to start to be familiar with. Additionally, throughout all 4 years, there's definitely a ton of extracurriculars, which obviously you guys know you're here. That's a great job already. There's tons of computer science clubs and things you can join. If you want to do something that's every month, those are great for that. If you're more interested in kind of like a one-time thing, you can do a lot of different hackathons. Those give you a ton of opportunity to get familiar with writing code, a lot of times on teams. It's all experiences that you don't get quite as naturally in a classroom, so they really give you this opportunity to have an experience that is going to be really valuable when you're looking to do interviews and then actually take part in internships and full-time positions. Some other things listed there, app development, open source projects are all great if that's something that interests you. I will say that the one caveat is don't just do this to fill out your resume. Make sure it's something you're passionate about. If you put it down, then we're going to probably ask you about it. And if you didn't really do anything with it or you didn't care about it, it's a little bit evident. I mean, I understand getting experience, but try to find something that is really going to make you excited to work, because there are so many different kinds of like hackathons out there that hopefully you can find something that you actually have an interest in and want to learn for your resume. All right, sophomore year. So basically what this is just continuing to grow your skills in computer science, where you're going to start learning data structures and algorithms, and this is the meat and potatoes of what the interviews are going to be about. So the sooner you have a good handle on these, the sooner you're going to feel really comfortable in a technical interview. This is generally what we're looking for. In a way, your sophomore year or whenever you take these classes is going to be the year you're probably at your freshest for technical interviews. So even as you continue to learn more advanced things, always come back to them. Make sure you have a good, solid understanding. Additionally, you can continue to work on these independent projects, start taking on team projects, and look into smaller roles on larger projects. Kind of just continue to expand whatever kind of base you've built up. Okay, junior year. Now you might start having proficiency in multiple languages. Languages aren't really a measuring stick we actually go by, but you will have to know at least one to get through an interview, and more than one gives you the flexibility to have a stronger one you can choose. Having stronger knowledge of kind of the more complex things in computer science is good. Big O, that's also a big thing that you learn about in these technical interviews. Also, hash tables, trees, those sorts of things will come up, and it's important to feel comfortable talking about them with another engineer. Having a knowledge of operating systems is cool, but probably not necessary for an interview. And software design, that's something that it just kind of comes over time, especially if you're doing those side projects. You kind of start to learn how you approach problems, how you would design code that's not going to fall apart in 2 weeks, how another person could come, look at it, understand it, and add to it. That's something that's really important when you get to the real world, and having experience with that and understanding is a great skill. And then a solid foundation in math, which you probably will have established at that point. Okay, so senior year. This is kind of the big year where it's time to start looking for full-time jobs. So obviously you want to be proficient in everything we've already talked about. Having internships is also a really great way to have that proficiency. It's a really great way to have stories that you can talk about in an interview, discuss the different kinds of things you worked on. At that point, if you have a company, they're going to be solving real-world problems, so you're going to be able to talk about the way your code contributed to fixing those problems. And that's really exciting and gives us a very clear insight into what you know and how you can use your knowledge to apply things to problems. And then also interview prep, which is what we're going to be talking about. That is key. I'll mention it again later, but for me, the #1 interview prep was practice questions. I got all of my questions from Cracking the Coding Interview. For me, this is basically one big plug for that book, which they are not telling me to do, but is 100% the reason I was able to survive the interviews that I had to get to Google. Practicing, if you have a friend who is extremely patient, practice with a friend. That would be great. And really kind of make it less scary to be in front of a whiteboard. You know, that's not a normal place you are to write code, so it takes some time to get adjusted to it. But once you're there, at least that part of the problem is no longer an issue. You're really just thinking about like the skills and knowledge that you've gained throughout your 4 years. And then finally, getting advice, referrals from former interns, people who have been through the process, is also super helpful. This is a great start. Just a quick note, I have been interviewing for about a year as well, so I've not only been in your position, but I've also been an interviewer, so I can hopefully answer questions from both sides. All right. Before we go through anywhere further, does anyone have any questions? Yeah. They could. It's not ever going to be something where you're, deriving some crazy equation. That's not what they're looking for. They're looking for just general, like maybe calculus. I think like probably not worse than algebra, because even in the real world, like the programs you're writing are not usually doing something super intense mathematically. So I think just knowing that you've taken calculus and knowing that you know how you could apply the math that you know, whether it's just basic algebra to programming, is kind of all you need to know. So I would say generally no. They might start a question with like, how do you calculate a line? And then they go from there and you're going to start writing programs. So okay, so the question was if you haven't had a lot of time majoring in computer science. I think that's where the extracurriculars really come into play. There are tons of online courses, so I would assume you didn't have as much time to take all of the kind of extra classes like the operating systems, compilers, things like that. You can take those classes online. It's obviously a bit more effort to put into it, but there are ways to get caught up. People can self-teach themselves just about anything. So I would definitely recommend doing that and getting involved in those group programming things, because then you're probably going to be working with people who have more experience, who might be able to point you in the right direction for resources and also just teach you as they go, which is, I think, the best way to learn. Yeah. Oh. Mhm. Mhm. Right. So the question is, outside of Java, C++, and Python, are there any other languages that you might need to know? We'll cover this a little bit more, but generally, no. Not for a company like Google. We're not going to ask you to program in some arbitrary language that you wouldn't have any familiarity with. The only chances of that is that if you listed it on your resume, we might be curious about it and ask a little more information. But if it's not on your resume, we're not going to surprise attack you with a brand new language. Mm-hmm. Right. I still would say no, especially because Google mostly is interviewing for general engineers. So although you might have an inclination for back end, we're still going to be testing the data structures and algorithms that you'll use regardless of front end, back end that you're doing. Yeah. In the back. Oh yeah. Hmm. Yeah, I'd say it's more the general expectation. I have different questions based on the kind of role. Like if it's an intern, an engineering practicum, full time, but usually everyone's getting the same question. That allows for just honestly fairness across the board because you're judging everyone against the same question that you've asked. And also, it means that I know the question really well and can help anyone through any problem, which is nice. Yeah. Yeah. Um, I'm a procrastinator, so I did this about 3 weeks. That's not what the book recommends, and I recommend everything the book recommends over what I did, which I think is a few months. I mean, it doesn't hurt to read it ahead of time. If anything, like if you're in school, there's something you don't know. Maybe it's just you haven't gotten to it in class. So it's kind of nice to track what you're learning and how it's going to actually come up in interviews. So it's not like the funnest book to read, but it's good. And it's also not as big as it looks. Like the last 2/3 are just solutions. So don't be intimidated by the size. You could just read through it. Yeah. Mhm. Um, it kind of depends. It's really interdependent, really. The answer that you want to be giving is optimizing for both space and time. So if you're writing a solution and it's going to take, n squared, but there's a solution that's just n, that's when a lot of times interviewers are going to ask. And even if you did come up with the optimal solution, they might ask, how fast is this run and why is this the right solution? So it's usually you're going to write programming, but you probably will be asked runtime, space, time, complexity. Yeah. 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 That's a good question. It depends from school to school. I usually feel like the kind of clubs that you guys it seems like are actively in will probably post listings of things that are happening. I know a lot of different schools in the area sponsor hackathons, and that's a good way to get to know people just like right away. And then from those people, they probably know of ongoing projects too. So I would say hackathons are probably a great way to get to know people who are active in the like outside of classroom developing activities. All right, we're going to move forward. So now we're going to start talking about the actual interview. So the first part of the interview is going to be this new thing we have where we give you an online coding sample and you are given two different technical problems and an hour to solve them, I believe. Yeah. And but what you do have is time to practice ahead of time with this tool. I believe you have up to 2 weeks to submit your answers. So use this tool, try it over and over again, and test out how it feels just to be writing in this semi-timed environment. Additionally, you'll have a survey that talks about work style, but that you shouldn't need to prepare for. So this is something that you should definitely take seriously. Obviously, don't Google it when you Google answers when you're doing this. We want you to be honest. We want to see what you can actually do on your own time. And this gives us a good insight into how you actually program. It's kind of the closest chance you have to like real life coding. It's going to be your computer in your comfortable environment, and this is really your chance to shine. After that, we have actual interviews, and those can either be on the phone, on campus, or on site here at Google. Generally, how they run is the interviewer comes in, gives a short introduction about themselves, does the technical assessment, usually involving a whiteboard, sometimes using a Chromebook, and then leaves time for you guys to ask questions of the interviewer. That's your chance to ask, what's Google like? What's coming up for me? What's your experience been at the company? Things like that. One thing that's important to note is a lot of times that people think Google does all these brain teasers, and they don't. That's just, if something feels like a brain teaser, it's probably something that you should just attack in a brute force way, or just kind of handle it as logically as you think it could be handled, because a lot of times things might seem like there's a magic solution, but the person is not looking for a magic solution because it doesn't exist. I think that's why we might get that reputation, but no one's going to ask you why a manhole cover needs to be round. That's just not relevant at all to your job. So, and then the engineering skills, what we're actually assessing, not just random facts, is language syntax. That one's, depending on what you're interviewing for, more or less important. Interns are not expected to have quite as clean code. Algorithms and data structures, as I've talked about before, a lot of times these questions are geared towards focusing on one of these data structures or algorithms that we want to just make sure you have familiarity with. So that's something we're going to be looking for. Analytical skills, this is solving the problem, just how you approach something when you come in not knowing the solution. We don't expect you to hear the question and have an answer pop in your head. We want to see what steps you take to get to that answer. And then last is sound design. Again, this depends on the question, how big it is, but designing something that makes sense to someone else is critical when you're a software engineer. You want to make sure someone else can see your code 2 years later, understand what it's doing, updating it, and moving on, and not completely confused. And that's what good system design looks like. It's just making sure things make sense and are broken apart in sensible pieces. And also, just by the way, when you're doing a phone interview, those are on Google Docs, which is a little unfortunate because they are not meant for writing code. But so just prepare yourself for that. Here are the categories of questions. We've got coding, which is just kind of inherent in all of them. Math, those are probably as much as you're going to see to reiterate the math question. OS, maybe less for, I think, new grads. Algorithms, definitely. The big O analysis, like I mentioned before, is important. Sorting, searching, graphs, all that stuff. And then data structures. So hopefully if you've been taking the intro level classes, these are going to start to look familiar to you. And these are things that you're just going to keep using and reusing no matter what kind of problem you're solving. So definitely important topics to take note of. Okay, so to get more in depth with algorithms, it's how would you solve this problem? So how would you sort it, search, represent, solve? Can anyone just throw out some classic sorting or searching algorithms so we get an idea? Quick sort, nice. Merge sort, good. Bubble sort, less good, but good answer. What? Insertion, good. Do we have any searches? Binary? Cool, awesome. That's really the only one I can think of right now too. Cool, so and then knowing the efficiency of all those. So knowing why you would pick quick sort, not just because of the name, but over bubble sort. Things like that are good to know and justify. Someone's gonna ask you, okay, you wanna do that, why? And that's really good to be able to answer with kind of the technical terminology. Oh, for the approaches, one last thing is listen to hints. That's something that I've run into as an interviewer is if I'm mentioning something, I don't care if it seems super unrelated, I'm leading you somewhere and no one is trying to screw you up. They want you to do well. And like I said before, I'm doing the same question over and over again. So I've seen basically every iteration of this solution and I know where people get tripped up. So just make sure you're in tune with the interviewer. This is really a discussion. We want to see how you would work with us because we're going to work with you if you get hired. So it's just really important to make sure that you're not just focusing on your whiteboard. This is somewhat, you want to go back and forth, talk through everything with them. If you're a kind of person like me who likes to think quietly, all you have to do is say, I'm going to take a second, let me think about this. And then when you come back to the interviewer, come back and say, this is the way I just reasoned through these things. Just give them a quick rundown of what you're talking about. It really helps the interviewer to know what exactly you're stuck on and what they should be pointing out to you. And if you're just silent, I don't know if you've just given up or you don't care or you're basically solved the problem, you're just going to spit out a whole bunch of code. So keeping the interviewer involved is really, really important, which I just covered with this slide. Is there anything I didn't say? Listen to the interviewers, trying to help you. Yeah, pictures is definitely a thing a lot of people look for. It's kind of each person's opinion, but I always describe computer science as being described in circles and squares and arrows. And if this is a question where you can draw a network or a database and who's communicating with who, a lot of times just drawing out a simple diagram is super helpful. Okay, so how to prepare for this interview. Definitely review the fundamentals. Like I said, with the Cracking the Coding interview book, it covers all those fundamentals, but you don't have to buy that book. You can use, for the longest time, used my own books that I had for my first 2 classes in computer science. Definitely thinking out loud, talking out loud is super helpful, even if it's to no one in the room. It's a great way to start realizing how you think through problems. It's good to be familiar with your own problem-solving approach before you start doing it in front of other people, because it just makes you realize that maybe this whole time you've been solving problems, you didn't realize how you were getting to the answer. You just were getting to it. And I think speaking out loud helps you identify what the actual approach you've been taking this whole time you already know how to do is, and it makes it a lot easier to then communicate to an interviewer. Practice writing code, definitely a thing. If you need to, definitely practice on a whiteboard, since that is a little weird. I think everyone knows, including your interviewer, they hated writing on that whiteboard as much as you, and they're not gonna like hold it against you for not having this like perfectly structured whiteboard code. But it's good practice if it's something that's gonna distract you while you're doing your interview. And if you need any accommodations, definitely tell your recruiter everything. They are there just help you get through the process. So be very open with them. Definitely tell them about the language preference you'd like to write in, because if you give them the preference, that means you're going to have interviewers that know your language, can help you through the problems that you might get stuck on. And that's super useful, especially as an interviewer, that I'm not sitting there trying to debug a program in Python that I haven't written in Python in like 5 years. So it's really nice to have said that ahead of time, so you get the people who can actually answer your questions helping you out. And then last, like we mentioned before, if you know anyone at Google, definitely feel free to ask them questions, ask them about their experience. Everyone has their own version of how they got here, so it's cool to get a lot of different examples. Okay, so this is what the interviewer is thinking while the interview is going on. As I mentioned before, how did they analyze the problem? Just kind of how you approach big problems is super important to know. It's what we do on our day-to-day basis. When you're given a problem, how are you going to fix it? Understanding how you approach that is great. Also, acknowledging edge cases, that's important. It means that you're not just going to take the obvious, easy example, assume it works, and then walk away. If you know how to fix the edge cases, that means there's going to be a lot less bugs, and that's important for all software engineers. After that, we have, did they approach the problem methodically? Kind of ties hand in hand, just do you make sense? What else do we have? The produce working code and then testing the code. This is something that sometimes you may not have time for, and it's not really a make or break, but having the initiative to mention testing is honestly a huge thing. Just showing that you know that all code should be tested, that not everything you write the first time is gonna work is great. And if an interviewer is pushing you to test something, definitely test it. There may be a bug they're trying to get you to catch, and they want you to find it instead of point it out themselves. And like I said before, having the code be clean and easy to read is good, explaining things. And then last but not least, I'm sure you guys are all fine in this department, are you pleasant to work with? Don't be a jerk. I mentioned a little bit before that the phone interviews are a little bit different since they're in a Google Doc and on the phone. I wouldn't worry too much about the font situation. It does look better, but we don't care. Copy and paste is great. It's basically do your best, but we know this is a Google Doc and not an editor. We don't care that you didn't have the exact number of spaces to properly indent. We get it, but don't make one big straight line of everything back to back. Definitely be sure to be loud and in a quiet enough space that the interviewer can hear you. That's one of the hardest parts about phone interviews, is that I can't always hear what the person is saying. And that's very frustrating because you can only ask what so many times before 45 minutes is over. So definitely make sure the person can hear you. Okay, so we've covered that topic. Does anyone have any questions about the specific interview, on site, on the phone, anything like that? No, covered them all earlier. All right. So now what we're going to get into is an example question. We're going to kind of work on this together. Our example question is, given a 4x4 grid of letters and a dictionary, find all the words from the dictionary that can be formed in the grid. Now, this is not what you do in an interview, but what I would like you guys to do is list off some things you should not do at this moment if you were given this question. Yeah. Start writing code. Good. Yes, don't do that. Anyone else? Anything? No? Okay, well, you read my mind. Common mistake. Don't immediately jump into coding. Why this is bad. We don't know what you're doing. We don't know how to redirect you. Everything is about this discussion and making sure you're not just plowing ahead and then suddenly you're at this dead end and the interviewer is just trying to catch up to where you're at, in your head. The worst thing that could, worst sounds aggressive. An unfortunate thing that could happen is you start writing code, halfway through you realize this is not going to solve your problem, and then suddenly you've spent 15 minutes of 45 going down this wrong path, and that's really not an ideal situation. So you want to make sure you avoid just jumping into code because you've heard over and over again you need to write code. That doesn't mean you need to write it in the first 5 minutes. Okay, Mistake number 2, not running through an example. Now, some interviewers may give you an example. It may be too simple. Maybe you need a slightly more complicated example, or they might not give you one at all to see if you're going to come up with one on your own. Now, this says do stick to a simple example, but I will add don't make it too simple. So like for this example, we're talking about a 4x4 grid, and you're trying to find words within it. Don't make your example I or A. Like, you're going to miss something if your word is only one letter long. You want to try something that's complicated enough to cover the base cases, but not so complicated that you get lost within your own example. And think about an edge case or two. Thinking about those ahead of time means there's less debugging later, and debugging on a whiteboard is somehow even worse than debugging in any other situation. So definitely think about some edge cases. And be clear with your example. Don't just kind of come up with something vague. Like, definitely come up with an exact word. Well, in this example, you would come up with an exact board and a word you could form out of it. But you don't want to waste too much time on these examples. It's a balance, basically, of not rushing into code, but you're going to want to write code. I know some of these things can seem a little contradictory, but it comes together. Just remember, 45 minutes is short in the long term, but while you're sitting there, you have time. They're not giving you questions that you're not going to be able to get to the point they want you to get to in those 45 minutes. Okay, another mistake is when you do finally get to writing code, you want to make sure you're writing real code. Pseudocode does not count, but one thing that is super helpful is using helper functions. This has saved my life on many occasions. If you're given a problem and you know how to solve half of it, and you don't know how to solve the second half, write a method that just solves that second half, and you'll come back to it. Come back to it because it's going to distract you. Basically, if you're going to, you have to loop through something, and then while you're in that loop, do X, and you don't know how to write the code for X, write the loop, write a method that says do X, and then keep going. But make sure you're writing it in a way that's proper code. But what this does, it gives you a chance to kind of step back, solve a different part of the problem, and come back to the part that you don't understand yet. Maybe it'll become clear as you're writing the rest of the code, but helper methods are great. I love seeing people write helper methods. It means that they, A, understand how like general code is written, and B, it means that they're able to take a big problem and break it into smaller pieces. And then don't mix real code and pseudocode. If you're gonna write any pseudocode because you're trying to explain the overall design in the first 5 minutes or so, that's fine. Just don't start writing real lines of code right underneath it. Actually, like, go to a separate spot and write the code. Lots of mistakes. All right, common mistake number 4. Force-fitting solution to a similar but different problem. I'm not sure if this is like that common, but if you have this like super strong instinct that this problem should be solved exactly like this other problem you run into, but the interviewer is not exactly guiding you towards that situation, consider the fact that it might not be the right solution. There is a chance that it's similar but different. We know that there's a lot of questions out there on the internet that people say we do at Google, we keep track of those. So it might look like that question, but we're not asking that. So make sure you're taking into account all the details and, again, listening to what the interviewer is saying. And don't just, like I said before, we're not expecting you to just pop into your head having the answer. Just work through the problem. So, common mistake number 4. Okay, common mistake number 5, getting stuck on optimization before any coding. This is actually a really good one. I think because we mentioned how runtime, space complexity is important, people want to get the right solution from the very start. But what's better than having half-written, completely optimized solution is a fully functioning, less optimal solution while discussing how you could optimize. I think if you can't think of any solution but the brute force solution, go with the brute force solution. It is not a bad thing to start there. Every software engineer does, even in the real world. So there's a chance that the brute force is halfway there, and then you're going to optimize it later. Definitely think about getting a solution first, and then talk out loud about how it's always fine to give a warning, be like, hey, I know this is a really slow running solution, but this is what I have right now. And then they're more likely to work with you from that point to realize that they know you know how to solve it and you want to work at it better than just kind of jumping in and starting to try, doing something crazy optimized that you don't fully understand why you're doing yet. All right, now we're finally done with mistakes. So, things that you should be thinking when you're in an interview. Thinking about data structures, thinking about which ones are going to work best for this kind of problem. I think what this says, where a bad choice will make things seem complicated and time consuming, is a really good thing to notice. If you pick something and all of a sudden everything is about updating that and tracking that and how much time it's going to take to insert and update things like that, you might not have picked the right data structure. And not every question is looking for like a tree or something complicated that you haven't seen in a few years. It could be something more straightforward. So don't just force in a complicated data structure to show that you know it. If it works, then definitely use it, but don't use it for the sake of using it. Like I mentioned before, a lot of times we're looking for the more basic stuff. If it's something that's super complicated, we probably haven't used it in a while either. We're not trying to like be like, do you remember that one class you had in September and you never talked about since? That's generally not what we're looking for. So, be realistic on what kinds of things you should be using. Every once in a while, there might be something crazy, but for the most part, we're reasonable people. Okay, so we're back to the question. Here is a grid, and you're given a dictionary, and you're trying to find all of the valid words. So what is the first thing we want to do? Anyone? I already gave you this as an answer. Anyone? Yeah. Perfect. Yeah, exactly. Ask questions, clarify the rules, get more info. So in this case, the answer is yes, they can go in diagonals. And another thing we can do is make an example. Here. Okay, so we have an example, land. And then we're asking clarifying questions. So we just said give a dictionary. A lot of times these questions might seem really vague, and that's probably intentional. We want to make sure that you're gonna ask clarifying questions. That's something that's really good, a really good signal for someone who's curious and wanting to solve a problem the correct way and not just throw any answer on the board. So in this case, we're gonna say a dictionary is an object with an is-word method. And then here we answer the question of, can we go in all directions? The answer is yes. You start at a letter and you move out to an adjacent letter, and if it's a word, save it. So that's, I assume, how most people would solve this without a computer. This is also a really good way to handle interview questions, which is figure out what you would do if you didn't have a computer. A lot of times that's a pretty efficient solution, and if you can code that, that's probably a good solution to use. Okay, so this sounds like graph traversal. Woohoo! So we have two different ways to traverse graphs. We have breadth first search and depth first search. So here it explains that we care about the word and we don't care about the shortest path. We're trying to get all of the words. So maybe that's not the best option. Depth first search is that we can do it recursively and it will take less code. So that is the method that as a group we've decided because I just told us we did. Okay, so are we ready to code? Now we want to think about the edge cases. Can anyone mention, I might already, yeah. Can anyone think of an edge case for this problem? Right. Repeat a letter. Yeah, that's a great question. Definitely, you don't want to repeat a letter, but that's something you didn't know going into that, so that would be clarified by the interviewer. So it's definitely an edge case of, okay, I'm recursing through all of these different things, and I'm back at the letter I was started at. What do I do? The answer is don't, and make a method that won't call that letter. Another thing is this is a specific size grid, and you don't, as you're traversing through the different parts of the grid, you want to make sure you don't run out. You could go outside of the bounds, and that's something to check for too. And as this mentioned, thinking of those things ahead of time make it easier to code instead of finding them later. Okay, so here is some code, and it's in Python, which I already admitted I don't write in. But so check with your interviewer to see how much they want to see you put into the code. A lot of interviewers want to see like the real data structures, algorithm solutions, so they're not going to worry about the boilerplate code. I would say 0 interviewers want you to use imports. You can ask, but I would almost guarantee you they're going to say no. So don't worry about like super boilerplate, but things like the main method and the way that classes are formed is something that you can definitely ask. Is this something I need to check? Also ask like for arguments. Do I need to do like sanity checks about is this going to always be a valid argument that's passed in, or could it be null? Could it be a weird negative number. Things like that are good to ask, but a lot of times you'll be told, don't worry about it. Just focus on, like, assume best practices. Okay, so for here, this is a good example of where you might have a helper method. So like I said before, let's say we're not totally sure how you're going to find all of these words, but we do know that we should start at every single block in the grid and try to find all the words from that point. So this is an example of just writing the method that does that. It iterates through all the different parts of the grid, and then it calls a method recursively find words, and that's going to take care of the difficult part later. So already we're showing that we understand what the problem is going to require, what it needs to do, but we haven't, we're not getting stumped up by this part that we're not sure about. So now we go to recursively find words. Now I have prepared for this talk and I still couldn't get myself to read through this whole chunk of code. So if your code looks like this is, I've been told, functional code. That's okay. This is a solution and it's valid, but it's obviously not ideal. If you have a way to write clean code, that's the way you should do it. So what this is doing is having, I think, 8 different if statements, and it's going through each one, checking every single direction that you can go in. It does work, but it's not the prettiest code that you've probably ever seen. So if you start to notice this as a pattern, maybe think about how you could make it look a little bit cleaner. This here is a little bit cleaner. So this is still the same recursively find words method. Now it's just using 2 for loops that are nested and going through each section, calling it, updating the new spot in the grid, and then adding these words to the list. So this would be the ideal solution. As you can see, it involved kind of some design, thinking about having a method that calls another method that's going to be recursive, having using proper data structures like a set, having a good algorithm approach, so deciding that you want to use depth first search as a good choice, and then just making sure everything's clean and readable. So this kind of covers like a very typical interview question that you're going to get. If you're worried because you read that question, you're like, I did not come up with that answer in the 3 minutes I just gave you to go through it, that's okay. I didn't either. So it's really not a bad thing to feel like you don't know the answer to a question when you read it. You are going to have time. The interviewer is there to help you get through each part. So you're going to be, you'll have that chance to ask those questions where you're like, wait a second, now that I'm thinking about it, can I go back to that letter? Is that okay? And they're gonna be like, no, and that suddenly changes what you're doing. So it's okay to not totally know what to do when you first approach something. It's just the fact that you're gonna know how to go through any kind of problem, to use logic to solve problems, which in the end is what you've been practicing all along. So it's not quite so different from your daily homework and side project work. Okay, so we've written this method, and as I mentioned before, testing is a great thing to mention. If you can, definitely run through an example, specifically the one that you came up with is a good way to start. Talk about the evil inputs, kind of what I mentioned before. If the person did not tell you, you could assume that they're gonna always be good inputs. Talk about how someone could mess with your program, how they could hand in something weird and that would break it. If it does break it and they want you to fix that, figure out a way to fix that. And then, of course, there's the analyzing complexity. There's explaining why you picked the algorithm you did and how much time and space it's going to take up. And then walking through the code is also just a really good skill to have, and it's something that a lot of times becomes useful in an interview when, let's say, the interviewer lost track of exactly why you put this variable in a certain spot. If you walk through it, then everyone's on the same page, and that's a really good thing to know that your interviewer is on, because when they go away and write the write-up about the interview, you want to make sure they're explaining your code to the hiring committee in the clearest way possible. And then the last thing is they might ask add-on questions, and so coming up with alternative solutions is also really great, but not totally necessary. If you have them, and let's say you just aren't going to have time to write code for that, mention them. Mention everything you can think of for the question. The more you say, the more we know that you know. Okay. And I don't know why this is called homework, but spin-off questions is that this is usually kind of like the next level of the question. Depending on how much time you have, the interviewer might be adding more things on to kind of get more information, and it's always a good thing when they're asking more questions. So something like, how can you avoid searching the entire grid each time? Like, even a lot of times these follow-up questions are more discussion-based and less code-based, but it's kind of an interesting way to get more details about, like, oh, if you could cache a certain like search that you've already done and not go back to it and reiterate. That sort of stuff is really useful. Can you implement the dictionary? Print the actual path. What if the grid is... So these are all basically slight modifications to the question that they might ask you just to follow up, because you've already shown you have a strong understanding of the basic question. We want to see, what else do you know? All right. And as I hopefully have been making clear, just try not to worry that interviews are these conversations. They're not expected to be this flawless, I sit, you talk, and everything goes exactly as planned. You know, the small things like what's mentioned here, where writing as cleanly as you can kind of just help reduce the stress. It means I'm not stopping you to say, and what does that mean? And what did that say? It means you can keep moving forward easily, and you know, making it as clear as possible for me means that we're going to spend more time focusing on the problem and not the side stuff that doesn't matter. And again, it's not a one strike and you're out. You can't say any one thing code-wise that would be like, okay, this is not a good fit. As long as you're working through the problem, like even if you made a mistake earlier on, like there's always time to kind of like refigure things out, and just working through those problems is important. Okay, so final tips. No shortcuts, practicing a lot, like I mentioned before. Definitely be ready for questions about whatever is on your resume. The longer ago it was, the less likely it is we'll go to that, but it is technically something we're going to read, and if it sounds super cool, like I would ask a question about it. Doesn't mean you need to be completely an expert on it still, but it's good to be able to explain kind of a little bit about everything on your resume. I know a popular question is just talking about technical challenges and interesting times you run into on projects that you may have listed, so make sure you can think of a few good stories about the time you're writing code for your app that did who knows what. Being able to talk about it in a technical way is a really great way to have a good lead-in to what sort of like areas of strength you have. And then repeating what the interview said back to them is definitely not a bad idea. Clarifying constantly is a great idea. And just basically communicating as much as possible is super important. Okay, and they put this on the last slide, which is why I mentioned it sooner, but Cracking the Coding Interview is there. That is a great book, but there is also a ton of other places that you can go to get more examples. If you go through all the Cracking the Coding Interview questions, you're amazing, but there are other places to get more resources so you don't feel like you've completely run out of things to test. Oh, yep. I thought I saw the cameras go down. There we go. Okay. We'll just leave it on this slide. So that is, how much time do we have? Oh, cool. That's pretty much all I have. Does anyone have questions? We have some time. We've got about 20 minutes for questions if anyone has anything. Yes?
How many questions are asked during an interview, like, generally?
Mm-hmm. You mean in, like, one interview? Like
a 45-minute.
Oh, that's a good question. I would say usually it's one major question with follow-ups. A lot of things, like questions that we look for, are ones that can be expanded on, so we can stretch them or shrink them to meet the level of the candidate. So it's usually going to be about one topic. Sometimes people do two shorter ones, but in general, I'd say it's one with maybe additional follow-ups. Yes. Mm-hmm. So I think a lot of our electrical engineers are software engineers when they get here. There may be some more opportunities in hardware, which I wouldn't know as much about, but we could definitely get a recruiter in here that can talk about it. But yeah, a lot of people who have like ELE, or whatever your abbreviation is, electrical engineering backgrounds, they do the same software engineering interviews and just they write code. Yeah. It probably wouldn't be as important that you've done like networks or something, although maybe that's something electrical engineers would do anyways. But just the basic classes, the data structures and algorithms are going to be important no matter what major you're coming from. Mm-hmm. Pretty much the only difference is that interns will all be either on campus or on phone, and you do 2. And full-time is almost always on site, and you do 5 plus a lunch. Yeah, it's a full day process. Exhausting but fun. Yeah.
Is there like a set number of interns that you hire each year?
That's a good question that a recruiter should probably answer and not me. But I think someone will come in here at some point and we can ask that. But I think it's not totally set, but it is based on how many people are able to take on an intern. So like as a software engineer, we like decide whether or not the team can like have an intern project and if there's work to be done. So it definitely varies, but I don't know if there's like a hard limit or not. Yeah. Yep. That's a good question. So the question was, are we only interviewing for software engineer? When you say computer science, like as a major? That's usually a good prep for software engineers. I was a computer science major. So I think that usually goes hand in hand. I don't know if, I'm sure there is computer software engineer major, but it's anything related to computers is a good prep, I would say. Yeah. Sorry, did that answer the question? Okay. That is a good question. I know we have like site reliability engineers and they do kind of like DevOps, developer operations type thing. They keep servers up and running. They write some of their own code. We also have program managers. We have designers. And then a ton of other positions that I don't know very well. Those are kind of the main ones in the tech org that engineers would work with directly. But there's of course like sales and marketing, things like that. But yeah, I would say within the technical org, those are the other options. I feel like, is there a question over here? No? Oh, hi. Mm-hmm. Yeah. Yes. Oh yeah, those super exist. Those definitely exist. I So I know if you're talking about like product, project, program managers, those are also positions you can do at Google. They're still within the tech org. And I think there's actually a cracking the coding interview for that. There's a little chapter in that book about it. So yeah, there are other resources. As far as like marketing, digital marketing, sales, that stuff, that is definitely exists in New York. It's like a very strong presence here. I just don't know about it. And they're not going to ask you coding questions. I do know that. I'm not sure what their interview structure is like, and I'm sure there are resources online that you can check. Yeah. Oh, no, we've got everyone like that has a Google t-shirt for the most part, except for me, and clearly because I don't know that much, is a recruiter. So you should definitely talk to them. Yeah, the people who are organizing this events are all recruiters. Yeah, so hopefully if you don't have them actively coming to your college campus, you can reach out and ask about more events because we hold events for college students all the time for opportunities, and a lot of times you can apply directly through them. If they point you to the website, you can always apply on the website, but I think having a recruiter help you kind of like find your path is the best way to do it, so I would definitely recommend reaching out to like the recruiters like maybe as your school's chapter of whatever group you're in and say like, hey, we'd love to like have more interactions with Google, and then you'll get some recruiters responses for sure. Mm-hmm. Ah. Gotcha. Okay. Mm-hmm. I mean, yeah, there's definitely a lot of targeting colleges because we know that that's where people are coming out with CS degrees. But I would have to ask a recruiter how to get more in contact with one through not like college channels. I think applying is good. LinkedIn is definitely important to have like updated and stuff. They definitely scour LinkedIn and we'll check things out. We also hold a lot of events that aren't just targeted towards colleges. So like meetups and stuff, I think that there's probably a ton of Google people. Honestly, if you just get to know Googlers, we can refer people as well. So all of that is like a strong path in to applying. Yeah. Yeah. Ooh. Mhm. Yeah, totally. Googliness is funny because we use that to mean everything, which is not useful for people when they're trying to be it. In my mind, and I think in every interviewer's mind, it means that you're just easy to work with. You're nice. It there are not always nice people that are interviewing, but in general, it's just that you're open to having feedback. If you're doing something wrong and your interviewer is trying to guide you away and you're like, screw you, I'm right, not googly. It's easier to say what isn't googly than what is, I think. But in general, it really just, it's not something that you do or don't have. It just means that you're a good person and we want to work with you. Yeah. Yeah.
How long have you been working at Google?
Almost 3 years.
So, I have a follow-up question.
Mhm.
If let's say you start as a software engineer or you work in one technical field, is there a lot of room for growth, or how easy how easy is it if you want to switch, let's say, your focus, and if you don't want to do software anymore, let's say you want to do DevOps or something like that?
Yeah, that's a good question. So how easy it is to grow within software engineering is you have to. Google expects you to be learning and growing and getting promoted. So your managers, your mentors, everyone comes together and makes sure that you're being put on projects where you're learning new things, where you're getting exposure to more and more engineers. You're working with senior engineers, so you're getting good experience. So you definitely will grow just kind of naturally by being here. If you're interested in switching within engineering, we try to make it really easy to switch between teams. Let's say you've been working on like Docs web at some point and you decide you really want to know how like search backend works, like how are we doing all those results. That's something that you can do. We have internal job postings that what team's hiring, what they're looking for, and you can make that transition. So they make it really easy to kind of get around. You can even switch, offices, teams, everything. They try to make that super simple. And then if you want to choose or change ladders, which is what we would say, like there's an engineering ladder, there's a product manager ladder, there's a designer ladder, that sometimes will involve doing usually like an interview or two. We also have a lot of programs that let you try those out. I know for sure there's a program that's like a 6-month rotation as an engineer testing out being a PM, and that doesn't usually require any interviews, and that kind of lets you stick your feet in the water, see if that's something you actually are going to enjoy before you make the full transition to a different role here. Yep. This is where it sounds less glamorous. My day is a lot of me sitting in front of a computer, which I like. It means I'm writing code. I'm on a pretty small team, and we have enough work to have kind of near constant focus. And we do have meetings usually like once a week. Engineers notoriously hate meetings. I actually like them, but they try to keep them minimal. And so usually there's like a weekly meeting for my team, and we discuss like what we're going to be working on, what we already are working on, and general more higher level things. And then I go back at my computer and I work. I write code. Beyond like what it looks like from the outside, it involves emailing people in different offices, asking about how their libraries work, and figuring out what the best resource is, and talking to my coworkers, like, does this make sense? Everything gets code reviewed here. So any piece of code you write, you send to a coworker, they read it, they respond, write comments, and go back. So there's a lot of communication that's happening that way, and that's also how you become a really strong engineer. Oops. So that's it looks like I just sit at my desk all day, but there's lots of things happening. Yeah. Yeah. Mhm. Yeah. So the question is, will we keep pushing you till we find the limit of your knowledge? Kind of. So that's kind of where I was talking about the questions that can be stretched and shrank to fit the candidate's knowledge. Yeah, if we're asking you like a fifth follow-up, we're probably really impressed and just trying to see like what you know and how well you know it. I think that there's plenty of questions that have infinite complexity if you keep adding on different things. So we might have those questions in our head and have no intention of asking them, but if you blew through our question in 20 minutes, and we're not going to just stop the interview because you're here for the day and we've got to fill up 45 minutes, we'll probably keep going. So if it feels like you didn't finish a question, that might not be a bad thing. It might just mean that that person is really good at hiding their face and their reaction, and that they're just expanding it or adding on a new question. There's definitely been times that I've given interviews where the questions that I use that normally take up 45 minutes took up 20, and I've got to ask more. And it's not like answering those wrong are going to like retroactively ruin your previous answers. It's just a chance for me to get to know how good you are. Like you already probably passed a certain bar that I was expecting, but now you're kind of in unknown territory. But it is dependent on interviewer to interviewer. Yeah. Mhm. Mhm. Mm. Yeah, definitely. I actually did not come to Google straight out of college, so I came from another job. And I would say like the biggest difference is your resume is like you're going to have job experience, and you want to be very clear with how big of an impact and how useful you were at your current job or past job. And that's going to be almost more interesting to them than, your grades and classes, because the real world experience is great. I think that interview-wise, everything's basically the same. But you bringing to the table a real world experience is definitely a good thing. And they might have a slightly higher expectations depending on how long you've been out in the industry, but that's usually within reason because you've been in the industry doing it. Yeah. Mm-hmm. Mm-hmm. Not a universal one. I think I'm allowed to say. I'm sure there's something we all say that we do, but having worked on a couple different teams, everyone's different. And it's based on a lot of times how big your product is, how important it is that you don't break it, and how big your team is. So Agile just doesn't necessarily work for every instance of the different teams we have at Google. And they generally don't mandate anything company-wide because they recognize that there's, everything should be customized to be productive for your own team. Mhm. Definitely didn't specify in the beginning. But I think they're starting to change this. I think since I didn't come straight from college, it might not be the same, but I went through the interview and then passed hiring committee, and then any team that was looking to hire could see all the people who would pass through hiring committee, and then they said who they were interested in, and then you can talk with the managers and kind of just pick from there. So there was like 2 different teams that I was choosing between. So it wasn't like all of Google. But there was a certain amount of decision, and I knew coming into it what team I was going to join. I don't think that's always the case, but I think they're working to make that more the case than not. Sometimes you might just be told you have a job, and when you show up, you are told what team you're on. Any other questions? Yes. Mm-hmm. Mm-hmm. Right. They definitely take your previous experience into account, and if it's something you want to pursue, like that is great. We like the idea of someone who can hit the road running. Is that how you say it? And so I think that's good, but you definitely don't have to. we hire general engineers. So we're looking for people who, when given enough time, can learn and pick up whatever skill they need to learn. So if you're like, hey, I haven't had a chance to ever do, massively scaled back end because I just graduated college, that's okay. That doesn't mean you can't work on it. You are being hired because you've proven you've got the basics, the algorithms, the data structures that you need to know to solve basically any problem. So it's not about necessarily having the expertise beforehand. They'll put you where you want to be, hopefully. Yeah. I think Ruby is one we definitely don't use very often, but it depends. Obviously for like apps, Android's all in Java, iOS is in Objective-C, and a lot of our servers are in Java. Go, which is like a language Google invented, we like that. So it depends on what you're making, and usually a lot of teams obviously at Google are already formed, and they're going with the language that they picked back in the day. But for new teams, there's this like some room to decide who you want, or not who, what kind of language you want to be using. But it's a little bit more restricted than maybe just like your average startup company that's just picking the newest technology that's out there. Mm-hmm.
Is it common to have engineers who did not go to school for computer science, or how common is that?
I don't know stats. I do know it's a growing group since I think we're in this point where a lot of people maybe went to school, realized that software engineering is in demand, and then went back and did their own version, like education, whether self-taught or not. And it's definitely a path to Google. I don't know what the stats are though.
But let's say like you interview two candidates, they both are equally good, but if one went to school for computer science, do they get preference, or are they like, do they get any sort of preference?
That's a good question for a recruiter, but I would say they know, like everything, once you're into the interview, like it's about how well you did on the interview. It's not like, I would say the only difference is maybe like years of work experience. Like if you've been in the industry, doing something, that would be helpful. But for the most part, like by the time the resumes get you to the interview, and then the interview is where we're basing a lot of things off of. It's all about the skills that you've shown there. Anything else? I think we're okay. Yeah, I think we're just about done. Unless I can take a few more questions. Yeah. Yeah. So they're just this 5 of the same, the 45-minute structure where, a person's going to come in. They're going to be 5 different people. And you'll have a lunch interviewer as well where they are not judging you. They're just there to answer your questions and let you have a chance to eat. Yeah. Yeah, it's all coding. Algorithms, that kind of thing. Everyone has their own variety of question they like to ask, so it's not going to be like the exact same thing. We also make sure that you're not being asked something where the answer is binary search every single time. We're trying to cover a range of different topics, and so as an interviewer, we see who else is on your list and kind of know what questions you've seen before. So we're hoping to cover a broad thing. So if there's one thing you don't know, you shouldn't be asked about that 10 times. No, not really. That's part of the in the coding. It goes along with the vagueness of the Googliness. Is yes, the person who is interviewing you to write code is also paying attention to how you act, and making sure you're not being mean. But that's kind of the extent of the behavior type interviews. Yeah, it's different than a lot of other kinds of jobs you would interview for. Mm-hmm.
So if you have 5 interviews in a day, are they separated by category, or it's just random questions being asked in every interview?
More random. Okay. There's less randomness behind the scenes, but for you, it's just 5 separate questions that each candidate or interviewer has decided to ask. Okay. Anything else? Yeah. Right. There. Well, since we have a recruiter here now. What are the things you look for on a resume to screen through who should get to a phone screen?
Sure. So there are probably about 4 different things we really look for, 3 of which will show up on a resume. So one is your coding proficiency. So that's usually exemplified by projects that you've done, internships that you've had, experiences that you tell us about. The second is leadership skills, because when you come to Google, you're not only coding the entire time, you're also
Cool. Well, if there aren't any more questions, it was great talking with you guys. And have a good rest of your time.